Hi, I'm Paul Grossman, and today we're going to be talking in the next two videos about lexical analyzer framework design. This is going to be an update to a presentation I did back in 2009 at HP Discover, where we talked about a lexical analyzer that could identify could generate code directly off of plain English. Now, in this case, we came across a bit of an issue when we tried to upgrade this demo for this year, and we had to add in optical character recognition in order to have that work. So let me take a few minutes here to kind of explain exactly how that went about. So I originally said, why don't we say if we could take plain English, like a line of string, a line of code, or plain English, and convert it to a line of code. Like here I've got click on the OK button, and I want to convert it to a line of code that is executable dynamically. So the way I did that was I said, okay, well, we're going to have an array, and we're going to split up this string into its elements. Click on the OK end button, and we're going to reverse it so that it says click on the OK button in the array that we're going to process through. And as we're going through, we're going to go and look for any of the prepositions in the English language and remove them, such as on, the, in, and from, and just leave us with what we should have as a method and a description and a fairly close to a web element description of a class, of an object class. So once we've done that, we're going to go through the array and start looking up and trying to find little bits and pieces. Now, the first thing I want to do is figure out what the parent is, and in this, for this example, we're going to be using we'd be using a browser, and we'll use index 0 as the description for the object. For the browser, I'm just going to say that this is the only browser that's available on the application, so we're just going to stick with that. We're not going to actually specifically name it. It's just one browser that's out there, and keep things rather simple. In this case, if we had identified that there was a dialog, we would change the object type to a dialog and use index 0 on that as well. You also see that we're consuming this. If we had found it, we're taking the array element and setting it to nothing if we found the dialog and the name of the dialog that came with it. In this case, we're just going to go with the browser as a default, and there's nothing to erase because it's the default. We didn't find browser out there, so we're going to just do that default. In this case, the next thing is we're going to come through is see if we can identify what is the object class. And as we find in here, we have button being the object class, followed by the description of that button, which is the OK button. So button isn't actually an object class, web button is. So for the items that are web classes, we'll take the button, the list, the table, and the image, and append web to it, and that gives us our object class of web button, web list, web table, web image. And again, we are clearing out and consuming these items from that array. Link is one of the exceptions. There is no such thing as a web link, so we just pass link directly through. And again, clear out the consumption. You'll see this as we move to the next array. Now we've basically blanked out those items in this array, and we're now looking to see if we can figure out what property we're going to use to identify these objects. So in this case, if it's a web button or a web list, generally developers were going to use the name property, and we'll put it in as name : equals as part of the descriptive programming that we'll build in a moment. If it happened to be an image, a web image, we would use src, the source, where we'd most likely find the match for the description of the object that we're looking for. So we now have the object class figured out. Lastly, we have to go look through and see if we can find the method that we're going to execute. Well, it could be either click or select. Either one of those would end up doing a click on a item or selecting from a list. If it happened to say enter or type, well, then we'd have to use set, which is the actual method that is setting an object to the value that we put in there, whatever data it happens to be. Again, we're going to clear out that method, clear out the array, and if there's anything left in the array, that's going to be the data that would be appended or entered into the value, into the object. but in this case we don't have any data in this description. So lastly, we go through and build our dynamic code. Our dynamic code said, well, go get the Windows type, which was a browser, and the programmatic description, which was index : equals 0. And then we go and add the object class, which was a web button, and then we're going to add the property and the value. The property was name : equals, and the value was OK. And lastly, if there was data, we would append that to that full string, and this is the full string that gets built out. Browser, index : equals 0, web button, name : equals OK, dot click. And if there was data to set, it would append out there. You execute this line of code, and you can go and click on a button. You've now just done a very quick translation of a low-level English sentence to a line of code. Now, that was in 2009, and we tried to do this in a small demo to show that there are, UFT does work with not only web browsers, but local applications as well, and I like using the calculator. And it was pretty easy to do the calculator at the time because we could actually interact with our calculator. So let's take a look at our calculator here, and here is UFT. We're going to go into a live demo here. Live demo. I'm not screen recording. I'm actually recording the screen directly off my camera here. So I'm going to go to live demo, and I'm just going to pick up this 5 button here and show you exactly where the number 5 appears so we can identify it. Yeah, it ain't there, friends and neighbors. Name has been removed as an identifier for this object, so we can't even identify that 5 as a number. So how am I going to get my little lexical analyzer, which has plain English, where we launch a calculator and click on a button and verify that a number appears on our calculator? How are we going to get to identify these guys if they don't have unique identifiers? Well, let me give this a run, and we'll show you what it's going to do. So the first thing it's going to do is convert that launch calc into a function that will launch the calculator. That message box that just popped up said that it is going to be the pass version of this run. There's 2 of them. There's going to be a fail. And we are now identifying objects out there. You can see it actually flashing the objects as it goes along. And it's also giving us a recommendation not to say just check that the 35 is there, verify that 35 is out there. But it figured it out on its own. And now it's going to do the exact same thing, except it's going to do it with a failure. It's going to say, what's 7 plus 5, and does it equal 35? It doesn't, of course. There is 7, and there's the plus button, and there's 5. Now, because we're using optical character recognition to identify these objects, it does go a little bit slow. We did pop up a message that says, hey, we couldn't find the number 5. We found 12 instead, and we reported a failure. So our 2 test cases, 1 passed and 1 failed, and those are self-closing dialog boxes that are popping up there. Now here's our actual output, and we'll go and take a look at our data and see what our data has out there. Our data, here we are. And this is what we originally said was our plain English. Our comments to say what exactly it was doing. And it is generating lines of code to actually go out and execute out here. Let's see if we can pull out the lines of code a little bit and give you a little bit of seeing of what it's doing. In this case, it generated launch calc, which actually went and ran calc right over here. And it also gave us some objects to interact with, looking for the 7, the plus, and the 5. And because it couldn't identify those objects, it had to go to optical character recognition on that. And it generated other lines of code on the fly that it created and executed, and then finally verified all these objects. Here's a good example. We're setting a global object equal to the parent object and the class that's underneath it to find our objects and interact with them. All right. In the next video, I want to show you the code behind the scenes on how all of this executes.